The first problem we were assigned to is number 2. The period of a pendulum is given by t equals 2 pi square root of L over G, where L is the length of the pendulum in feet, and G is the acceleration due to gravity. This means that G is a constant, and this constant is 9.81. And T is the time in seconds. The pendulum has been subjected to an increase in temperature such as that the length has increased by 0.5%. This means that it has increased by 0.5%. Letter A says to find the change of the period of the pendulum if the original length is 4 feet. This means that L1 is 4 feet. And we need to find L2. This we can find it with the data that it gave us that the length has increased by 0.5%. If 0.5%, then how many per 4? Then you multiply 4 times 0.5 and divide by 100, and it gives you 0.02. This number is the DL. This means that L2 is 4.02. Then you have to find the change in the period of the pendulum. This means the change in t, delta t. For us to find delta t, we need to find t2 minus t1. And for us to find each t, we need to plug in L2 in its corresponding t. So we first plug in 4.02 into the equation, and that gives you that T2 is equal to 4.022. Then we need to find T1, and we apply L1 into the equation to find T1. This gives you that T1 is 4.012. Then you subtract T2 minus T1, and this gives you that delta T is equal to 0.01. This is the change in the period of the pendulum. Letter B says to find the percent of the change. For us to be able to find the percent of the change, we need to apply delta T over T1 times 100. Since delta T is 0.01 and T1 is 4.012, we need to divide 0.01 by 4.012 and then multiply that times 100. This gives you an answer of 0.249%. This is the percent of the change. Letter C says to find the approximate percent change in the period. This is associated with dt. To find the approximate percent change, we have to divide dt over t1 and that multiplied times 100. For us to be able to do this, we first have to find dt. dt is t prime times dl. T prime is equal to 2 pi times L over G to the exponent of a 1/2. This is a power rule, so we have to multiply that 2 pi times 1/2 and then subtract 1 to the exponent. This will give you negative 1/2 as an exponent. Then you are able to simplify this and find that t prime is equal to pi over square root of L over G. Then this you multiply it times dl, and we know that dl is 0.02. This gives you that dt is equal to 0.02 pi over square root of L over G. All of these you have to divide by T1, that is 4.012. Now we know that G is 9.81, so we replace G by 9.81. And we have to use L1 in the letter L, so we use 4. Then we're able to evaluate this, and we find that dt over t1 is equal to 0.0238. This you multiply it times 100, and it gives you 2.38%. This is the approximate percent change in the period. Letter D says to find the approximate error in the pendulum clock in 1 day. We know that delta t is equal to 0.01 and dt is equal to 0.09. So we suggest that the approximate error in 1 second is 0.08. And so, if we want to find the approximate error in 1 day, we can say that if 0.08 is the approximate error in 1 second, then what is the approximate error in 1 day? And we know that there are 86,400 seconds in 1 day. That you multiply it by 0.08 and divide it by 1. And this gives you that the approximate error of the pendulum clock in 1 day is 6,912 seconds. This problem acts as a pendulum clock. Not all clocks have the same accuracy. This is why we have to find the approximate error, since every clock has a margin of error where they can be wrong. So this means that not all clocks are as exact as we think. This is why we need to find the approximate error in each clock. The next problem that we were assigned to was number 12. Number 12 says to find the antiderivative of 14 square root of x times x to the second minus 5 over 2 square root of x plus pi dx. The first step is to rewrite. You change all the radicals, square roots of x's, to x to a 1/2, for us to be able to multiply and make the distributive property. Then you are able to make distributive property. And when you multiply x's, you have to add its exponents. These exponents cancel each other. Then you're able to find the antiderivative of each term. The first term is a power rule, x to the n. So you have to subtract n minus 1 and divide by n minus 1. The second term is just a constant, so you only add an x. The next term is also a power rule, so you do as the first term. And here you have your answer. At the end, you can simplify by changing the exponents of fractions into radicals and multiplying the coefficients. At the end, you add a c that is a constant. And here you have your answer. As you can see, the blue graph is the antiderivative of the red graph. This makes sense since the derivative of a quadratic function gives you a linear function, so the antiderivative of a linear function will give you one quadratic function.